Good morning there, boys and girls, children of all ages. Today I have an exam, so if I don't solve it within 15 minutes, I am going to have to cut it short. This is a series of video where I try to solve a Leetcode easy problem within 15 minutes. Okay, so let's just go ahead and open up a new page and go to leetcode.com. And we're going to do a randomized easy problem, so hopefully I get an easy problem on the first try here, so I don't have to like go through a million other problem. That's a medium one. That's a medium one. Medium. Medium. Hard. Easy. Okay. I have 15 minutes. Let's do this until 10:40. My time today is so very limited. You are given an integer array gift denoting the number of gifts in various value pile. That's right. Every second you do the following. Choose the pile with the maximum number of gifts. If there is more than one pile with the maximum number of gifts, choose any. With the maximum number of gifts, more than one, choose any. Okay. Leave behind the floor of the square root of the number of gifts in the pile. Take the rest of the gift. Leave behind the floor of the square root of the number of gifts in the pile. What? The gifts, okay, let's look at an example. Gift 25, 40, 64, 9, 4, 100, k go to 4. So what is k? Return the number of gift remaining after k second. Okay. The gifts are taken in the following way. In the first second, the pile is chosen and 10 gifts are left behind. The pile is chosen and 10 gifts is left behind. What does it mean? 100. This is so confusing. You are given an integer of your gift. Every second you do the following. Choose the pile with the maximum number of gifts. So these pile, we have gifts denoting the number of gifts in various pile. Okay, so this is 25 gifts in this pile. Okay, choose the pile with the maximum number. Okay, so in this case is 100. If there is more than one pile with the maximum number of gifts, if there one gift, choose any. Leave behind the floor of the square root. Leave behind this floor of the square root of the number of gifts in the pile. Take the rest of the gift. The final remaining gifts are 5, 8, 9, 4, 2, and so the number of total remaining gift is 29. Why? Oh, leave behind the floor of the square root of the number of gifts in the pile. Take the rest of the gift. The floor of the square root of the number. Okay, so 100 is going to be turning into 10, right? So let's say, look at this array. We have 4 times. So 100 is going to turn to 10. And the next time we do this, we kind of have 8 here. And the next time we do it, it's going to be 5 here. And the next time we do it, finally, is going to be, the maximum number is 10. So that's going to be 3. So 5, 8, 9, 4, and 3. 5, 8, 9, 4, and 3. Okay, so there's 2 steps to here. Find the maximum number inside the array. And then find the maximum number of the array. And then basically square root it. And then square root it. Take the square root of it. And then store it in the array again. Update the array. And keep doing that. And at the very end, return the sum of the number of gifts remaining. So what I'm going to do, I can probably sort the array first, and that's going to be of n log n. But depending on how many k second there is, it might be just quicker to just loop through kth in the kth time, and then just find the maximum, take the square root of that, and then yeah, I'm going to do that because if I take the square root of it, then the array is going to be unsorted again, and I have to sort the array again. So there's no point of me sorting the array. So what I'm going to do is iterate kth time and then find the maximum number each time. And each time I do that, I'm going to store the index, and then I'm going to take the square root of that and store it inside the array. And then in the end, I'm going to return the sum of gift. So no matter what, we're going to return the sum of gift. That's already an O of n operation. Time complexity This is really depending on how long k is. So that's n times k, like time complexity. So that's gonna be n times k. I want to say that is definitely not n. The time complexity is n times k. So for I in range, for I comma each in range of enumerate okay. No, that's not it. For I in range of, no, we don't need this. We don't, for in range of k. So if k is 4, it's gonna loop through the thing 4 times. So max int equal to the first number. So gifts gift at 0 gift at 0. So that's gonna start off with the array, and we can do for each and for I comma num in enumerate gifts. Index equal to 0. Let's just do int index equal to 0. Max index enumerate gifts. Ew, man, this is gonna be so messy. If num is more than gifts at max index, then max index equal to I. Okay, so that's gonna give us the maximum index. So that's gonna give us the maximum index each time we iterate through. And what we're going to do now is we're going to update the array so that we can do it. So gifts at index is equal to gift sqrt. Is that it in Python? Math dot square root. Okay. Gifts at index square. Okay, let me just look up Python. How to take the square root. Yeah, sqrt. Yeah, okay. Sqrt. How do we floor it? Floor. Okay. I square root. I sqrt. Forgive me. And then in the end, we're going to return the sum. And that should work. Okay. This index must be an integer. Okay. Max index. Run it. Gifts is not defined. Run it. I don't like this. Run again. Hey, that worked. Okay, so that worked. That is stupidly slow. Let's see what the top solution does. For gifts in num, convert to the negative by default on the min heap. Okay, new math equal to math dot square root heap push. Okay, so I guess they try to use a heap to sort to use this. Yeah, we can use a structure like a heap to do that. A heap will basically bubble up at the very top and then return the sum max heap. Max heap for gifts. Okay. This is not the most efficient solution. We are doing n to the time k. Because of time constraint today, I'm not going to try to solve this in the quickest way. I'm going to look at this later and then I'm going to figure it out because I do have an exam today. So goodbye. Okay, let me see.